Whiteboard, right?
Yes.
Okay. Okay, I try to explain que the money, bueno, the only thing lost in the record was the proof of this formula, no? And this formula is not complete. We need to introduce the new idea que es compounding, que es super easy to understand. Look, I know that my money increasing, pero increasing like stairs, because depending the periods que you receive the reward. Entonces, there are different possibilities. Bueno, in the initial supposition, you suppose annually. So my money increasing annually. So this is 1 year, 2 year, 3 year, and so on, no? But not necessarily always is annually. So annually is under the supposition that the compounding is M is compounding, is equal 1. So one step of these stairs is 1 year. Pero no always is like that. Semi-annually, for example, semi-annually is n equal to. Entonces cuando n is equal to, es because my money increasing for half a year, o sea, es 6 months. So this one is no 1 year, is 6 months. This is 12, que es 1 year. O sea, semi-annual is twice, 2 times in 1 year. But you have another possibility, quarterly, 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 quarterly is 4. So the stairs is increasing in 3 months, increasing, 3 months, increasing. So 4 times in 1 year, and so on. For example, monthly is 12. Because that depends the account you create. There is a compound interest with the compounding monthly, okay, or weekly, or daily. No, daily is crazy. Daily is 365. No? Okay, my stairs in 1 year have 365 steps. Entonces, you refine this formula, reformulate the formula using the new idea for the compounding. The future value, que es capital A, is equal present value 1 plus R over N, because the supposition is que R is interest rate, but always annually, APR. Okay, therefore, si you want to express it, for example, monthly, you divide by 12, this APR. And multiplication by the amount of step que we have in our stairs, que es empty. Not always T. T is under the supposition que compounding is 1, que es annually. Pero si compounding is no 1, then the formula is different. Okay, this is my final formula. Actually, let me summarize in detail the formula. The formula is, look. This is the future value formula. Future value is equal present value 1 plus R over M T. Okay, this is my formula. Okay, good. Now I have another formula que is exactly the same formula, but in this case you isolate present value. Suppose que I try to make a plan. Entonces, in the plan, I have to get some future value, how many money I need to deposit in the bank account today in order to get in the future the determined money I need. Capital A is the money I need. Present value is exactly the same formula, but you divided by this factor. Is division. Therefore, you obtain the future value that you're planning to deposit now, today, in order to get in the, I don't know, 10 years, some money. Okay. However, we have one special case, a special case, in which you have no idea exactly what is the compounding. For example, so you want to determine the price of something, cup of coffee, I don't know, in the future. And you have no idea. So you suppose, the supposition is que M, que este compounding is infinity. Therefore, the formula change a little bit. It's a little bit complicated to prove that. But the formula is capital A is equal to present value e to the RT. So using exponential. Using exponential. This is the technical name of this is continuous. Continuous. This situation happens when you suppose que es continuous. Continuous. Continuous compounding. Okay? It's because what is the idea for the continuous? The idea for the continuous is supposition que this stair actually is no stairs. It's exponential. Okay, exponential like that. This is continuous. So now the width of the stair is 0, it's too small, and you can approximation the stairs like an exponential function. Likewise, or similarly, we can using another formula P, in which you isolate P, exactly the same here. You divide, or you put exponential with the negative exponent. So there are many ways, either way to express it, using division or using a negative exponent, that by the way is the same, right? Okay, this is the first 4 formulas that we are using in the word problem, no? To determine the investment problem. I bring 1, 2, 3, 4, 5, 4. 1, 2, 3, 4 problem using that formulas. Entonces I highly recommend que you follow me with the calculator, no? Everyone follow me with the calculator. Any questions so far? Any questions so far? Do you understand the big picture for the interest? Any question? Any question? Okay, no problem. Let's see the example. Example 1. Okay, example 1 say if $10,000 is invested in account at 3%. I suppose que 10,000 represent the present value, no? And this interest, this 3% represent the interest rate R. Let me identification. Compounding quarterly, compound quarterly. That means N is 4. The question is how much will be in the future, will be in the account in 5 years. 5 years, suppose que es the time. If no money is withdrawn. Okay. Entonces now the formula que we are using is future value is equal to present value, 1 plus R over N, everything raised to the NT. This is the famous compound interest formula que control the mathematical relationship in which the money increasing. Okay, by the way, somehow look like exponential. Okay, entonces the information is given is present value is 10,000. Interest rate is 3%. Very important, very extremely important. You never plug in 3 here in the formula. No. Because in the formula, the consideration is that this is in decimal. So immediately you convert to the decimal. You divide it by 100. Okay, it's exactly the same. Move the decimal place 1, 2 places to the left. Now, one more information we have when we have compounding, 4. And we have T, get 5 years. And substitution, because I want to find future value. It's the money and 5 years. Go. Okay, A is equal 10,000. 1 plus 0.03, que is the interest rate expressed in decimal, divided by 4, and raised to the NT. And who is NT? NT is N is 4, T is 5 is 20. And this 20 represent our money increasing like that. In 20 steps, and this is stairs. Okay, it's 20. 20 is the multiplication, NT. Now calculator. You put in the calculator. Please, everyone, put in the calculator. In the calculator, you put in the display of the calculator. I suppose everyone have a calculator. Suppose this is the display of the calculator. You type in something like that. 10,000. Open the parenthesis. 1 plus 0.03 divided by 4 power 20. This symbol indicates power, no? In any calculator. The majority of calculator. Entonces 10,000 es the answer. Yes. The answer, pero es, you forgot 1 0. You forgot 1 0. You forgot 1 0. It's 10,000, no 1,000. Parenthesis. 1 plus. Okay, no problem, pero you get the idea. 0.03 divided by 4. Everything raised to the 20 power. Bam, bam, bam. Press enter. It's 11. 11,000. Rub. $611.84. You truncate, you round to decimal place because we are talking about money, currency. Therefore, have no sense to continue one more decimal place. No. Leave it like that. Okay, super. This is my final answer. A beautiful final answer. This is the money that I have in this account. See, I know withdraw money in this account in 5 years. Any question, guy? Question?
I have a question.
Please go ahead.
How do you use this specific formula?
Ow, I don't understand anything. Your internet have some problem. I see up. Come on, try to speak slowly. What part you don't understand? How do you know what formula to use? Okay, good question. Okay, this is, we have one formula que stay future value. And we have 2 formulas que give me information about present value. It's obvious in this problem we are working with the future value. This is my unknown. Okay, present value, no formula. And we have in the future value 2 formulas. You have continuous and no continuous. And no continuous gets discrete. Get the money increasing like that. This is the formula for the non-continuous, discrete. Okay? Clear now? Super. Good. Okay. Entonces, let's move on to example 2. Thank you. Example 2. I try to erase the board. Boom. Okay, example 2 now. Example 2 is a little bit more complicated and interesting. Example 2 say, John wants to buy a car, a new car. A new car, the price of this new car is 30,000. Car. He planning this. He has saved 27. Almost, but not yet. Entonces, you need to deposit this 27 in one account. Entonces, find the number of year, Guys, pay attention because problems similar to this you need to do in the test and the Alex. Find the number of the years, plural, several years. Each will take for his 27,000 to grow to 30,000. At 4% in the account in the bank, compound quarterly. Okay, I am totally lost, but I try to collection the data, the information. This is, well, I suppose that this is the future value, yes or no? Because it's the money that he wants in the future. And the present is the money that he has now, today, save 27. This is 27. It's a present, future present. Find the number of years. Oh, the unknown, and my problem is T. I have no idea. How many years I need waiting to grow the money from this to this? And the interest rate is 4%. And the component quarter is 4. Okay? So when you hear about quarterly, this is not continuous. It's discrete. And the money increasing like that. And this step corresponding with the 3 months. 3 months, quarterly. This is the time. This is the money. What money? Well, the money that you have in this moment, no? So you stop in one time, the stick is exactly I'm looking for in order to get the money. Okay. So one more time, I select that formula, right? Okay, no change. We select this formula again because it's non-continuous, a discrete problem, but the information I need is time. So I need this time. Okay, but don't worry. Use substitution, plugging in. A is 30,000. A is 30,000. P is 27,000. Paréntesis, 1 plus R is, remember, you immediately convert it to decimal. 0.04 is 0.04 divided by 4. And raised to the NT, N is 4. And T is exactly the unknown. The quantity I try to looking for. But in this moment, well, we have the exponential equation, I suppose. Exponential equation, remember exponential equation is the equation que the unknown is located in the exponent. Entonces now, why not? You divide both sides. My goal is solve for t, do something, divided by 27,000, both sides. It's obvious. Can cancel out this 0. Well, this is gone completely 1. And divided by 3 is 10, and divided by 3 is 9. Okay, and the right hand side we have, wow, it's easy, it's 1 plus 0.04 divided by 4 is 0.01 raised to the 40. And this together is 1.01 raised to the 40. Wow, very, very nice. Okay, so let me write my equation so far. My equation is 10 over 9 is equal 1.01 raised to the 40. So this is the classical no, special exponential equation in which to solving this you need to apply logarithmic both sides. What kind? One standard. A standard may be natural or may be common. Either way, the answer doesn't change. In my paper, I don't know why I apply natural both sides. In that moment, I applied the property number 7, no? And the property number 7, remember, is fantastic because allow me this exponent move to the front as a factor. So we have logarithm 10 over 9 equal 40 logarithm 1.01. Finally, this equation is no logarithm anymore, and now it's linear equation, super easy. And you divide both sides because my goal is solve for t for ln 1.01 both sides. So my final answer is then logarithm of 10 over 9 divided by 4 logarithm 1.01 is equal to t. And now calculator, because I need to determine how many years I need to waiting to get the money que I planned. So I put in a calculator. Be careful with the calculator. Suppose that this is the display of the calculator. And the display you put, I don't know, you put LOG or LOG is okay. Or LM is okay, it doesn't matter. Open the parenthesis when you press this 10 over 9, close the parenthesis, division, you put division, you put the another parenthesis because this parenthesis is important because you need to enclose everything in the bottom by one parenthesis. 4 times multiplication, this is time multiplication, log of 1.01 and close two parentheses. If you write without these parentheses, you are in big trouble because you need to indicate the correct order of operations. Let me try my calculator. Everyone working with the calculator now. LOG or LN, it doesn't matter. 10 over 9. Close the parentheses, division. Open the parentheses, can close everything in the bottom. 4 times multiplication. Now press logarithm again equation. 1.01 and close two parentheses. Tum. Press enter. Boom. I get the answer. I waited for you. How many years? How many years? 20 years. Exactly. 2.65. 2.65 years. Well, she rounds. Actually, in the display of my calculator, have a 2.647161115. Entonces, bueno, depende del problem. Suppose que the problem say a round to the near 10th. I want to say a round to the near 10th is 2.6. Suppose 10th here is 2.6 years. Si you need to round to the near 100th, bueno, entonces es 65 because the next digit is 7. Okay, good. This is the good answer. Depende the problem specification. You round to the specific. Okay. Don't worry, get the test and the Alex online specification. Express your answer using only 2 decimal place, or you 1 decimal place, or 4 decimal place. So this idea is always clear. Don't worry for this. Any question? This is a little bit more complicated, right?
I have a
Go ahead.
why
I don't hear anything.
in the problem what you divide like you have 10 people 1 plus 0.01
Okay.
the 4.
Your question is, because I don't understand very well, Miss. Your question is about this step. This step is okay for you?
Yes.
It's okay. Now this step is not okay for you?
Yes. It's not okay.
No.
No,
Well, the only thing I did was, look, in this step, I divide 30,000 divided by 27,000. No? If you want, you put it in the calculator directly. But I did by hand. Look, you eliminate 3 0. And here, reduce and lowest term divided by 3 is 10, divided by 3 is 9. However, in this step, it's super easy. The only thing I did was addition 1.00 and 0.01. No? This is plus, is 1.01. This convert to this. This is the arithmetic, basic arithmetic. And the rest, do you understand or no?
Yes, I do.
Entonces, you understand the complicated part, and the easy part was not clear. Okay, let's go to another problem. Okay, an easy problem. Okay, example 3. And no more. Example 3 of the money and investment. Okay, example 3 is find the future value. Find the amount A is the future value, so the money in the future that result from investing principal money P of 2,000 at APR 8%. But this is equivalent to say R. Compounding continuously for 1 year. Immediately you hear the word continuous, this suggests me que we're using the formula for the continuous, que es future value is equal present value e to the RT. No anymore that formula. Present value 1 plus R over N raised to the NT. This is when the money increasing like that. Boom, 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 boom. And this is the money increasing continuous, like exponential. So you select this formula because the problem say the supposition is continuous. This keyword indicate me, select the formula, that formula. Entonces es super easy. Because P is given, que es 2000. I need to find a future value is equal to 2000. Multiplication, of course, this is period, time here. Exponential E, que exponential is the same, bueno, it's the same, no. In our calculator, we have one key que es log. Another key que es LM. Associated with this is 10 to the x, este exponential associated with this logarithm, and e to the x is the exponential associated with this logarithm. So this e is this. So we use this function, and you select this function, press the key second first. I don't know si your calculator is blue or is yellow or is another color. So in the exponent, I put a APR, que es RT, 0.08 multiplication by time, que es 1 year. So this is the thing I try to put in my calculator. I put 2000. Okay, wait. Let me try to describe the display. The display you put 2000 time, and you select the function time, and you select the function second LM. Entonces you see in the display something like that. E power parenthesis, and inside you put 0.08. Well, multiplication by 1 or no, or you will make the 1 because 1 is invisible, no? You put it inside 0.08, close the parenthesis, press enter, bam, bam, and you get the answer. Okay, I wait for you. I get the answer in my calculator. Now, I wait for you. Come on, guys, it's part of the game today using the calculator. The calculator is important today. I told you, no? This is the answer. Very, very well. This is Roof. Roof always help me. The answer is $2,166.57. No, it's okay, Angelica. Cent. Let me see, Michael. Yeah. Okay. Because it's 57, yeah. 57 because the next digit after 4, so you ignore. It's negligible. Okay, this is the answer. Any question, guy? I promise que in the review package, okay, I want to say, so today is Monday, Wednesday we continue working with that part, and now next week we spend the entire week doing the review. Yeah, I will send the test on paper, right? We almost finished. This is the test 4. After the test 4, the student can get A or good grade, or when you average every test, you believe that this grade is good for you. You don't need to take the final. Remember, the final is not mandatory. The final is only for the students that for some reason fail or don't take or skip or something one test. Well, no, it's for everyone. Suppose that you get B. You say, no, I don't want B, I need A. Okay, you take the final. And the final incorporates to the grade, different grade. I replace the worst test. Okay. Now, well, I have another. Yeah, I have another problem. About money. A little bit interesting. Yeah. I like that. What is the standard for the calculator? Ruth, I don't understand very well your question. What is what? Standard.
What that?
Say again?
The E. In the calculator.
Okay, I explain here. You don't see that part?
And
you have two keys that frequently we are using for the logarithmic exponential, no? Associated with the log the exponential is 10 to the x. Associated with the ln, the exponential is e to the x. We use it here, that part. So you press. Well, you press 2000, multiplication.
No,
okay.
Thank you.
Okay. Okay, let's do another. I need, can you help me with the calculator part? Well, no, calculator, no. Everything. Okay, this problem is about the bones. Example 4. Suppose a bone. You know, a bone is another way to investment. You buy the bone. Can be redeemed in 10 years. Okay, the direction, the maturity time for the bond for 1,000. So you buy the bond right now. I don't know exactly what's the price, but in 10 years you receive $1,000. Entonces the question says, how much should you be willing? Should you be willing to pay for it now if you want a return of column? Entonces we have two possibilities. One possibility is 7%, compounding monthly. And another possibility is 6%, compounding continuous. Continue, this is you, continue, you continuously. Okay. This is the problem that we have two possibilities, no? This is typical in the test. Entonces you compute both, you select the best way, so the best scenario. Okay. Well, entonces the first one is monthly. Monthly means que compounding is 12. This is a discrete problem, and discrete problem always we using that formula. The formula is future value is equal P 1 plus R over M and T. But in this problem, future value is given. This is the future value. Basically, I need to find the present value because it's the price that I am willing to pay right now for the bond in order to get $1,000 in 10 years. So no future value. And the unknown, the thing I try to find is present value. Present value is equal future value divided by 1 plus R over N and T. Okay, when I make a plan of something, remember John and the car have a money, if I want to plan one money, but what is the money I need now? Okay, in this case it's similar, right? It's a bond. To say what is the price of the acceptable price if you want 7% return. I'm planning this. Okay, so P is equal A, que A is 1,000 divided by paréntesis 1 plus R, bueno, R es 7, pero expresa en décima es 0.07. Es 0.07 divided by 12 because it's monthly, compound is 12, and everything is raised to the multiplication n T. and 10 years, so T is 10 years, and multiplication is 120. Okay, I put in a calculator, in my calculator. How you put in a calculator this? Well, this is the display. You put, first of all, 1000 division, parenthesis, big parenthesis, 1 plus 0.07 over 12, close the parenthesis, power 120. And present. Let me try. 1000 division, one big parenthesis, 1 plus 0.7 division 12, close the parenthesis, the symbol of the power, by the way, look like a roof of the house, and the exponent 120. 120. I get the answer. I need help. Okay, it's the answer. No. Something wrong. Sorry. Okay. Good. This is the answer, Angelica. Is 497. 60 cents, no? Approximately 60 cents because 59.6. This is the price. In the first auction. Okay, I need to get 7% compounded monthly. Okay, good. Now I've tried to compute the second option. The second option is different as continuous, and the continuous different formula. What is the formula for the continuous? Well, the formula for the continuous is future value is equal present value e to the RT. If you want to compute the future, but the present is future exponential negative, que es reciprocal. Okay, by the way, it's equivalent to say like that. P is equal A divided by e to the RT. This and this is the same. So you use a negative exponent, it's reciprocal. Actually, the new price for the condition 2 is 1000, que es future value, e to the minus the interest rate, in this case 0.06. 0.06 multiplication by 10, because it's 10 years, no? Be careful. When you put in a calculator, you put 1000 multiplication. It's a period, multiplication. The exponential function, exactly we used before. So when you open exponential function, automatically you put something like that, exponential and open parentheses. So e to the x. So let me try. You put 1000 multiplication, press the second LM, is exponential now. Now, okay. And now you see, wait. Let me try to write more clear this idea. This is power, parenthesis, and you put minus, because this exponent is negative, no? 0.00606. Be careful with this minus, because our calculator contains two minus. One minus is, in my calculator, blue, que es subtraction. No, this is no. Another minus is negative value. A negative value white in my calculator, no? Multiplication by 10. And close the parentheses and press enter. Minus 0.06 times 10 and close the parentheses and press enter. Okay. Okay, I'm waiting for you. Exactly, Angelina, is $548.81. This is the price in the second auction. Entonces using the common sense and your imagination, what do you suppose is the best auction?
A.
Exactly, because it's cheaper, right? Exactly, very, very well. Excellent. Be careful. When you need to be aware. For example, when you have to compare two possibilities, and you get a lower price and the present value, this is the best auction, of course. However, when the direction is opposite, and you find, suppose you have the same present value, and you find the future value. So the best auction is when the future value is bigger, is greater than, right? Because you get for the one constant money, you get more money. So depending on the direction, using your imagination, okay, suppose that you understand very well when you're talking about money. Everyone understand very well. Maybe when you're talking about another thing, you don't understand, but when you're talking about the money, everyone understand very, very well. Any question?
No, sir.
Oh, okay. Okay, let me try now to change another word problems. We have only 5 minutes. Let me try to introduce the typical problem is about growth population. Growth population. Okay. This is about biology problem, for example. And we are trying to find how many virus or how many bacteria, how many small microorganism or small animal like a rabbit maybe. Entonces the formula to find the model, so the population model in the small organism like a bacteria, virus, rabbit, something, cucaracha, insect, is a population to any time. In this case, no money is the amount of the bacteria, amount of insect, is P null e to the KT. I change the letter, no R anymore. And money is R, interest rate. In biology, no R is K. But it's the same idea. It's like it's the rate of change. In this case, is increase. Let me show you. For example, this axis is a time, T, just T. And this axis is P, que is the population. Population is amount of the insect, amount of virus, amount of bacteria. And P null, this is the initial amount. So we have the beginning 500. I don't know, 500. And at T equals 0, 500. This is the niche. At T equals 0. At T equals 0. P null is initial. And this increasing exponential like that. And you need to find how many bacteria we have at T equal maybe, I don't know, 5. But no, 5 years, 5 minutes, or 5 hours, depending, no? This is the idea for the growth population. Now, likewise, in the same family of the problem, okay, we are discussing, not today, sino next time, we have another exponential, but it's exponential decay. This is growth population, and this is decay population. And decay population is similar, it's the same formula. The same formula is not exactly population, it's amount of substance to any time is equal A null, que is the initial. This is the initial. Multiplication by A KT. What is the difference between this and this? The difference is when this growth population, K is positive, and when it's decay, K is negative. I don't put the negative here because the negative is the value of decay. And when this situation happens, the behavior is completely different. This is the time again. This is the amount of substance. I want to explain in detail next class. At t equals 0, we have one initial and decay like that. Okay, decay and growth is the topic that we discussing next class. Another more. Any question, guys? The time flies. It's only 50 minutes. 50 minutes. Okay? Okay, say goodbye. I gotta go. You too. Bye. You too.